Hello, good morning everyone. Good afternoon to some of you. I hope you can all hear me. We will start this session in about 30 seconds or so. Okay, good morning or good afternoon to some of you. Today we're going to do a free Netilities demonstration. And I will start by doing a small introduction on Procentec itself. We are a company fully dedicated on Profibus and Profinet, and now also looking towards other field systems, Ethernet-based systems as well. Our operational areas are Europe, Asia, Middle East, and North America mostly. And what we do with Profibus and Profinet is mostly field work, so on-site troubleshooting and support. We make network components, monitoring tools, and troubleshooting tools. We certify Profibus and Profinet products, and we also certify network installations. And we do trainings like these, and also troubleshooting and maintenance trainings, certified engineer trainings for Profibus and Profinet. My name is Joost van der Nat, and I am here with my colleague Lorenzo Fattori, and we will be hosting this webinar for you.
Yes, good morning all. I'm Lorenzo Fattori, and I'm here also today. I will not do the presentation, Joost will do that for today, but I'm here for answering all your questions. So if you have any questions, the tool is capable to give you a space for asking. I can answer for everybody, and I can answer for only for you if it's something more related to your network or something. But yeah, let's try to keep it open for everybody, and let's try to make it interesting for everybody. We will speak about Netilities, so we will speak about Profinet. And any questions, we are both from the support department of Procentec, so we are on site every day, like you, doing some maintenance, doing some troubleshooting when you have problems. So any question, feel free to ask. There is a question space. We will answer to you by text or even during the presentation. At the end, we will give some space just for questions and answers. Well, I think we can start. Joost, it's up to you now.
Thanks, Lorenzo. Some words about the history of Procentec. We started almost exactly 20 years ago, June 1997. And then after some years, we became one of the first test labs for Profibus in the world. And from that experience, we created Profitrace and later also the ProfiHub. And a couple of years later, we became Competence Center for Profinet. In 2014, we moved to our new headquarter location. And 2 years ago, we opened our Italian office. This is our office. We have a sales office and support office in Karlsruhe in Germany. And this is our office in Italy. And we have a global distribution network of dedicated distributors who sell our products locally in all in all regions of the world. They can also support our products. So wherever you are, or wherever your end user end customer is, there's always a distributor with knowledge supporting you. Our markets, it is very divided. Most of our end user customers are in food and beverage or are equipment suppliers. So as you can see, it is very equally divided. Our products and services can be divided into these 6 parts. The Profinet family, which was the product that started it all, and we made a newer version in 2000. I think it was 2006 or 2007. Then we also created the ProfiHub, and the ProfiHub is a multi-channel repeater, which easily can be used to divide networks and to extend cable lengths and to extend networks. Combining that caused us to create the Combrix family. Combrix is a modular repeater platform that can monitor the network health permanently. So it is permanently installed in the network, and it is also, it's not only a repeater platform, but you can also use it as a gateway to other media, such as Profibus PA. There is a fiber optic module, so not only restricted to copper Profibus segments. Our trainings and services is also a large part of our revenue. We also sell ASICs chips for Profibus and for Profinet, and we now also have tools for Profinet to monitor those systems, and that's what we will be focusing at today. We will look at Netilities, see what it does and how it helps you troubleshoot and maintain your Profinet network. So let's take a look. Netilities is a piece of software, and it is on a we call it an app dongle, which is a USB dongle, which also has the license on it. So it runs from the USB dongle. You don't have to install it on your laptop. It runs with an executable, and it needs to be on the license needs to be on the dongle. So you cannot copy it to your laptop. You have to run it from the app dongle. And when you start it, it pops up with a screen explaining 3 types of measuring the network. And each type has its own pluses and minuses. We will be using the first monitoring method today. I will explain that later when we come to the real demonstration. For Netilities to work as a monitoring tool, to record all the data going over the bus or over the network, I must say, you need to either have a tap, we call it a Profitap, or you can use a mirror port, and all managed switches support this feature. A mirror port makes a copy of a certain port that you want to monitor, and it sends all the data from that port also to another port. And you need to do this because switches are relatively smart instruments. Normally they only send data to a port where the destination is connected. So if you want to monitor that communication, you need to make a copy of that information somehow. You can do that with a mirror port. First, I will demonstrate how to connect or how to set up the interface correctly, so that Netilities monitors all the traffic. Then I will demonstrate the buttons that you can use to get more information from the devices, and what the colors mean, and what the live list indicates, and what kind of information you can get from that. We can show you how to set a Profinet name, and how to change an IP address if you want to do that. We can see if the configuration of a field device is the same as the configuration of what the PLC is expecting, and we can also see if there are alarms or if there is any other problem in the network. There are some statistics that I can show you. We will go into that later. There's a very useful feature. We call it the bar graph. The bar graph shows you if there are devices which have a cycle time deviation. So that means if a packet is missed or it's dropped somewhere on the way, then you will immediately see that here in the bar graph. Very useful. And also, maybe even more useful is the SNMP toolbox. I use this a lot when going into factories to do troubleshooting, because this is a method of very easily extracting or retrieving all kinds of diagnostics information from all the devices in the network. So this is an active way of getting the information to you instead of a passive listening method. When you do a SNMP scan, or after you have done that, then also a topology is available. This topology is in a tree view. Also very useful if you have colleagues in the field and they don't know what is wrong. What they can do is make a Wireshark trace. And this Wireshark trace or recording can be loaded into Netilities. And Netilities will then process this information and then display all the useful information in the live list, in the SNMP viewer. So you can also remotely or later load all the necessary information. Then there's also a IP selection tool. You can limit the range of devices that need to be scanned, and that can be useful if you have a very large network, and you can limit it to a certain IP range. All right, let's go to Netilities. First, a screen pops up, and this screen shows you what kind of measurement or monitoring options you have. First one is a combination of a Profinet, and the Profinet is connected between the PLC, between the controller, and the first switch, because this Profinet can record or send all the information that goes to and from the controller. It sends it on to USB. So this Profinet creates a virtual network interface, and your computer can use it to display all the messages. But there's one catch to this Profinet, and that it is actually one way only. So every data that goes in here, it will go to your laptop, but your laptop cannot send onto the network. And sending is useful if you want to do an SNMP scan, because your laptop will use SNMP messages to go onto the network. So to be able to do that, you need a second cable. And this second cable is a Ethernet cable connected to your Ethernet port and connected to a free switch port. This is the method that we will be using today. Another good option is to use a managed switch with a mirror port. I explained this earlier. The mirror port allows you to copy all the information from, for example, the port where the I/O controller is connected to your laptop. And then some switches also have the possibility of blocking outgoing messages so that your computer cannot send anyway. And then you can also use a second Ethernet port if you want to. And the last part is, the last monitoring solution is that you can use a normal switch and use a regular switch port. But in this monitoring method, you can only use it for SNMP scanning, which is still very useful. But you don't see all the information that is going onto the network. So you don't see alarms, you don't see missing packets, for example, but you do see all statistics which are gathered by all the switch ports. So I close this window, and then the first thing I do is go to interfaces. And there I select what network cards I want to enable. These are all the network cards in my laptop. I don't want to see the Wi-Fi, but I want to see my Profinet network and my Ethernet network, because we were using the first monitoring method, which was a combination of Profinet and an Ethernet port. So I click these two, I say OK, and what happens now is that my laptop is doing a DCP scan, and this scan identifies all the devices in the network. So the first identified device has IP address 0.1 at the end. It is a S7-1200 PLC, and the role is a controller. That's a good thing about Profinet. Each device has its own specific role and will also communicate this role to the rest of the network. The devices also have names, which have been registered or have been put in by the PLC programmer. And you can see the MAC address, you can see the manufacturer, and also here, this side here, the last received packet. So you can see that this is constantly sending and probably also receiving data. And the colors mean that green is that the device is in data exchange. So I have 4 devices in data exchange, and I have 1 controller here. And the switch, as you can see, it is also a device, but the switch is not in data exchange. And the switch does not need to be in data exchange. You can put it in data exchange with the controller, then it can exchange some extra diagnostics information. But in this network, it is just a standard managed switch. And the blue and the yellow colors mean that blue means that it is actively sending information, which is not Profinet data. So it's probably sending some IP data, TCP/IP, maybe SNMP, or any other related protocol. And yellow means that it has not sent anything for the last second or second and a half, which is a timeout that you could change if you want to. So if I double click on a device, it retrieves all kinds of extra information. And this extra information is identification and maintenance information. You can see the system serial number, the order code of the manufacturer, the hardware version, software version, software revision counter, things like that. It can be useful for registering this kind of information of your network. Next tab shows me the module configuration. And the module configuration shows me the configuration reported by the I/O device. So the actual configuration. And this is a it's an ET200S by Siemens. And the first module is a power module. Second module is a 4 digital input module, and then 2 digital outs and 4 digital outs. So this is the actual configuration reported by the I/O device. So Netilities can compare this to what the PLC is expecting. So here we see the same modules. So this device was correctly configured in the PLC. If I remove one of the modules, I'm doing that now, and I go back to the configuration reported, and I click update, it reads the actual configuration. And now I see that 1, 2, and 4 are there, but slot 3 is apparently missing. And if I go to the configuration expected by the controller, I see that that is correct because number 3 has no module, because I removed that module. So Netilities can show you what the configuration is, which is very useful at the commissioning phase. I've now put the module back. I update it once again, and now it is all okay. I can also use the auto update so that it constantly updates this status. If I go back to my live list, then I see that the ET200 now has an exclamation mark. And this exclamation mark means that there was a problem with this device. If I single click on this line, then in the bottom of my screen, it says this device with MAC address ending on C7 has 1 or more alarm messages. See details in additional device info alarms for more information. So if I double click this line and I go to the alarms tab, then I see the alarms that this device has created or has generated. You see the exact timestamp, I see the slot, and I see that the module or submodule with the name has been pulled out. It is a pull alarm. So this device can actually indicate that a module has been removed. And about 40 seconds later, you see that it is plugged back in. So you see that this device can indicate all kinds of information. If I switch it off, and then go back to my live list, then I see an exclamation mark here as well. If I single click this line, then you see here in the bottom that the PLC has sent a DCP request to find a device with the name ET200. So it's actively looking for a lost device. And you also see now that this this line has become yellow because this device is not communicating anymore. If I switch it back on and wait a couple of seconds before it comes back online, there it is. Now the exclamation mark also disappears for the PLC because PLC is now happy again. I go back into the alarms of this device and I see that there are 2 new alarms. And it says consumer DHT expired, which means something like the watchdog time of this device has expired. There are 2 alarms, 2 identical ones, because normally a device will send out, or the PLC will send out 2 alarms. So in the alarms tab, you can see all kinds of different alarms, which help you to troubleshoot and to monitor the network. And I can deactivate them all, or I can delete them all, and now everything is back to normal. I have some other buttons here, and I can use them to change the behavior of the device or change the parameters of a device. For example, I can change an IP address manually if I like to. I cannot do that while the device is running. So for that, I would need to disable the controller, and then I can change the IP address if I want to. Or I can even change the device name, because Netilities is a I/O supervisor, which is a different role than the controller and the device. And the supervisor is able to change device names. So I can change it to whatever I want. It won't work now because the device is also in data exchange. So I will cancel this for now, but you get the idea that you can change names. There's also a button to go to the web server immediately. So let's take the switch, for example. If I click on this button here, then it will open up the web server of this Siemens switch. And I can easily see settings or change settings or do whatever I want. This is a nice way of this is the way to set the mirror port. Go to the switch option here, and then you can enable or disable the mirror port. You can set it to the port that you want to mirror, and you have to apply a monitor port. So right now I am mirroring port 1, and everything is also copied to port 8. And there's also a button here to flash the LEDs on the device. So if you can imagine, you have a whole list of all the same devices here in your live list, and you want to identify one specific device, you click on this specific device, then you click on this this button here, and what it does, it sends a command to the device telling it to flash the LEDs on the device. So you can easily make a distinction between this device and the others. So you can identify it. Okay, we've seen this. Let's continue with the statistics. The statistics are, well, maybe a bit less useful. I don't use it a lot, but I want to show you anyway. The statistics show you different kinds of information about the device. The current cycle time. So what is the cycle time in milliseconds for all the inputs and outputs of this device? And you can see this is a matrix style live list. And this matrix shows the IP range of 192.168.0.0, and the last digit can be placed here. So every digit from 1 up to 254 can be seen here in this live list. So 192.168.0.2 has a cycle time of 512 milliseconds in and 512 out. This will usually always be the same. And I also see one other device, which is apparently not in data exchange. So it does not have inputs and outputs. And this is our switch. So it is correct that it is present in the live list, but it doesn't have any inputs and outputs. And the controller also does not have inputs and outputs because it controls other devices. And these devices, they have their own cycle times. I can also sort it on MAC address, and you have a live or a list of MAC addresses, each with their own cycle times. And I can also see the minimum cycle time and maximum cycle time. And this is important and interesting information because this is the current cycle time, but the min and max cycle time apparently have a deviation, as you can see. And that means that something has happened in this network. Something has caused the cycle times to change, which means that probably some packets were missed. And this is interesting information for troubleshooting. We will go into that deeper in the bar graph. There's a feature called, or a statistic called transfer status error counter, which is actually only for real-time or IRT networks. I don't come across it very much. It shows you corrupted messages, if there are any, and if the switch has marked them as corrupt. So normally a switch will discard a corrupted message, but for IRT that works slightly different. So that's why we have a statistic for that. The alarms from a device or from a controller. Apparently I have reset all the alarms. Let's create a new alarm by pulling and plugging modules in and out again. And now you can see that these alarms that I explained earlier can also be seen here in the statistics. Then there's a statistic called Profinet data size, inputs and outputs. So every device has its own specific input or output size, and the minimum is 40. So that's why you see 40 bytes in and out for every device. But the device can also have up to 1500 bytes or so. The absolute traffic of Profinet compared to non-Profinet, you can see that here. And blue means that it is updating or changing the value. So apparently this device has sent no non-Profinet packets at all, only Profinet. So the first part is Profinet and the second part is non-Profinet. And this device, and actually also this one, are sending also some non-Profinet data, which could be LLDP or ARP or SNMP, for example, some other protocols than Profinet. And you can also see that for the switch, it is mainly sending non-Profinet information because it has a web server. I have already opened the web server, the web browser, and that's why it is transferring probably some HTTP information. And this traffic can also be seen relatively, so in percentage. This device is only sending non-Profinet. This device is only sending Profinet, which can also be useful to do some troubleshooting. Because if you see that a device is heavily sending non-Profinet traffic, then you could investigate why it is doing that, because it should focus on its main task and not side tasks. And all this information also can be seen based on MAC address. So if you don't have the IP address and only the MAC address, then you can also see that here. Okay, let's continue to the bar graph. The bar graph is a very useful tool to see if there is any missing packets. And in this situation, you see that we have some red bar graphs. The bar graph height means or is related to the cycle time of the device. So these devices, 2, 3, 4, and 5, they all have a normal cycle time of 512 milliseconds. But you can see that some bars are higher than that. So if this device loses one cycle or misses one cycle, then the cycle time doubles from 512 to 124. And if it loses some more cycles, then it also doubles. So anytime a packet is discarded or corrupted or misinterpreted, then you will see an increase in the bar graph here. And this is very powerful. And as far as I know, we are the only company providing this information. So the bar graph indicates whenever a packet is missed. It doesn't tell you why, but it already points you into the direction of where you need to look. So I like this feature a lot. And again, you can also search based on MAC address instead of IP address if you like to do that. Also, if you have many devices, for example, say 100 devices, then you have a long list of bar graphs, and then you can use the sorting method. You can sort by IP address, or you can sort by the cycle time, min, current, and max. So if you have all devices with a fixed amount of cycle time, and you want to immediately see if there's one device with a higher cycle time than normal, then you choose this sorting method. just makes it easier to find deviations. And I can also freeze the screen. For example, if I want to make a screenshot, or I want to explain some things, or I want to make sure that nothing changes in my bar graph, and then I can unfreeze it whenever I want. And I can also reset the whole bar graph. Then it will take some time before it loads the bar graphs again. It takes about, I think it was 10 cycles or so, and one cycle is half a second, so that's around 5 seconds, maybe 10 seconds, and then the bar graph shoots back up. Yeah, there it is. Okay, let's continue with the SNMP scanning. The SNMP scanning is very interesting to me because it tells me almost everything I need to know. So as far as I'm concerned, this is the most important feature for me. The SNMP option is a scanner, and what it does, it scans all the known devices and also unknown devices if you want to do that. And for all the devices, it retrieves this SNMP data. And the SNMP data, first I will disable my firewall to make sure that all traffic is allowed. And then I say I want to use this this address range, and I want to I don't want to do the whole range, or I only want to do the devices currently in the database, which saves time because then it only does these devices and not the whole range of 1 up to 254. So I click OK. It will give me a warning. You can disable this warning if you want to. And what it does, it scans all these devices currently in my list here and retrieves the SNMP information. So let's start with the controller, the PLC. I click the PLC, and there is some basic information. I see only the uptime. So this controller has been running for almost 2 hours, but there's no data filled in, apparently no INM functionality. Maybe that is because my timeout was too short. Let me double check. We will do a new. We will do a new scan with a longer timeout. Yeah, it should take this address anyway. Let's try it again. Well, apparently this device does not have any INM functionality, but it does have information about the port that it has. This 1200 PLC has one Ethernet port, and you can see that here. Ethernet port, and then it's called X1P1, port 1. And the link state is up, so that means the port is running, and it's running on 100 megabits. It can also indicate if it is a fiber or copper port, but this PLC does not support this information. And this is the information that I'm most interested in. The relative port load, in and out, as you can see, in and out, and discards in and errors out. So if anything happens on the cable that this device is connected to, and the telegrams or the packets get corrupted, you will see that here in the errors in. So any corrupted packet will be counted here, and I will be able to see that. In this situation, we don't have any corrupted or discarded messages, because this system is now running normally. But in many cases, if there's something wrong with the cable, or for example, if there's EMC problems because of power lines too close to the Ethernet cable, then you will see errors in, or you can see discards in. And discards occur whenever there's a switch overloaded. You can imagine that if this controller is sending out and receiving a lot of packets, a lot of information, then the ports or the memory in the ports gets overloaded, and then it starts to discard messages because it just cannot handle so much traffic. So if there's traffic overload, then you will see discards here, and this is very useful information for troubleshooting. You can also see the relative load, or I can change it to absolute network load, and I can also auto update these port statistics. So it now constantly checks if there's new data, and it will display that here. So if I go to the next one, this device, the Siemens ET200, it has 2 ports. The first port is not used. The second port is connected to, let's see, it's connected to a switch here. And you can see that it is a full duplex 100 megabit connection, and it uses a copper connection. So this device provides me with a little bit more information. Also INM information. And I can see here that the absolute load is 6.6 kilobits per second. So that's not a heavy load, and that's good because you don't want a very high load of this port. It's only 0.05% of the full capacity. You don't want a load of higher than 20% normally. And here I can also see discards and errors in, errors out. And I can see this information for all the devices. This is the device that uses both the switch ports of the internal device, of the internal switch ports. Also, no errors in and out. Let's see, this device, also no errors in and out. This port probably has some problems with the implementation, because I see that the link state is down of the first port, and the second port does not support any SNMP information. So probably the manufacturer made a small mistake here. Then let's move to the switch, because the switch has many ports, and the switch also provides me all the SNMP data that I want, because I can see the system serial, system order code. I can also read out the system name, contact, location, things like that. And I can see all the ports that are being used at the moment. They're all copper ports, so no fiber optic switch here. And I can see the relative load for all the switch ports here. So if I have many switches, I just click on a switch here and here and here and here, and then I can see all the statistics of the devices, or at least of the ports, very easily. And this, for me as a troubleshooter, is, well, I think the most important information, because it directs me, it guides me to the problem area. Also convenient is the topology. You can see that the topology starts at the scaling switch. It puts the switch that has the PLC connected, puts it on top, and I can use these buttons to expand the whole tree all at once. And now I see that there's a scaling switch, and on port 1 there is a CPU 1200, that's the PLC. So the PLC is connected to port 1. On port 2 there is, let's see, this is our tool, this is our device. It is a Combrix PND001, and it uses port 1 of this device to connect to port 2 of the Siemens. And then it is linked on port 2 to another device connected on port 1, and there's another Procentec PND001, and it also has port 2, but it's not connected. Then port 3 and 4 are also not connected of the switch. Port 5, I see the ET200S, and on port 6 is a Agilicom Modbus or Profinet to Modbus gateway. And then also here in red, and red means here you have some information that this device does not support any topology information. So either it was not able to send its SNMP data, or simply does not support the SNMP protocol. So in tree view, you can also see how your network is built up. And that can also be useful if you see in this view that there is a problem somewhere. Then you can go to the topology, and then you can check where this device is located and to connect it to which switch. So if all this information has been recording during the time that we were doing this webinar, I can also make a report of everything that happened. I go to report, I click generate, and then I need to fill in some details. So network name is I can fill in some project details. And I can enter some remarks of what I think has happened to the network. For example, the ET200 has alarms. I need to fill in my my name and my company. And then I also can say I want to see a live list, or I want to disable it. I don't want to see the transfer status error counter because it's not interesting to me. I want to see a bar graph, and the alarms I want to see. And I want to see based on IP or MAC address. Let's do that. And I can load a logo. So you can load your own company logo in there so that you can give it to your customer. And then I click generate report. I will enlarge it. And here I can see the information that I filled in. and the Netilities version that I'm using. And there's apparently 1 controller, 5 devices, and 2 non-Profinet devices. And they're running at 512 milliseconds. I see that there are deviations. I see my remarks. And if I go to the next page, I see the tested subjects. There are alarms or diagnostic alarms. There's a difference between these two. So you can see that this device with this IP address has generated alarms, 3 alarms. Then there's a live list, so you can see all the devices in your network with also the color coding of the live list. There's the MAC address list with the current cycle times, the min-max cycle time, alarms. Here you can see that there's 4 alarms for this device. The data size, relative traffic, and here I see the bar graph, which I had reset just before we went onto the SNMP scan. So it's all green again. And additional device information. And this is all the information coming from the SNMP scan. So here also I have the errors in, errors out, and discards in. So in one view, in one page, I see all the relevant information for each device. So each device has its own page, and also the switch here. So this is even easier to see if there are any discards or errors and what the relative load is, because these are, for me, the most interesting statistics. And this report can be printed, or it can be saved directly to PDF. We have a PDF generator in there, so it creates a PDF for you, or you can of course print it directly to your printer. So all in all, this is a pretty small but powerful tool, because if you use the tools correctly, it will guide you to the problem area, and this is very useful for troubleshooting in the factory. Let's see, are there any questions? I'm taking a look on the screen of my colleague. Let's see, no questions so far.
So if you have any question about, just feel free to ask. Okay, so how do you import a Wireshark trace? Yes, it's actually correct. We didn't do that. It's pretty easy. Import Wireshark trace. Can we try?
Yeah, that's a good one, because I forgot about that. Let's stop this interface. Okay. And I will clear everything. So everything is now as it is when you start up Netilities. And I go to interfaces, and instead of enabling an interface, I choose process PCAP file. And let's see, I have some PCAP files here in my, let's see, for example, this one, Wireshark. Ah, yeah, I have, for example, this one. It's quite large, although it should be fine. So I choose a WinPCAP, or sorry, a Wireshark file, and I want to process it. And I have an option of using the interpacket delay from the file, which means that I load all the the telegrams in the same speed as they were recorded. But I don't want to do that. I want to load them all at once. And I choose start, and then it starts to load all the messages. This was a site where they were, it was a plant where they make medicines. It was a medical facility, and they had this automated warehouse. So whenever a new medicine was being made, a new batch of a certain medicine, the automated robots retrieved all kinds of different ingredients from the automated warehouse. So it was a huge place. I close it because it has finished loading. And as you can see, they are all yellow because right now I am not connected to that network. So it's not active. It is only a load of that network. And you can see the last received packet. This was my loading time. So this was just a few seconds ago. This was not the saving time, but the loading time. Let's see, I don't think there's much SNMP data. That's too bad. Maybe I can first load a database file. Because Netilities, I haven't showed you that either. If you have this information, you can choose save file. Then it saves all the information that you see here. So that means that you save also this device name, for example. So if I then process a PCAP file, let's choose a different one. Wireshark. Let's see. I'm not sure which one to choose. Let's try it anyway.
So just to be clear, the database information is all the database information that your device is collecting. And this means the Profinet name, the name of the device, the IP addresses. And you need this one to analyze a little bit more your pickup file, because in your pickup file, Wireshark is not capable to gather this information. Netilities is capable to send messages to the device and ask what is your IP address, what is your role, what are your SNMP information. Netilities is not doing that. Wireshark is not doing that for you. Wireshark is only displaying the messages that are traveling over your network, so over your mirror port or over your Profinet. If you have, so you need to have also the database file if you want to see all this kind of information. It's not mandatory. You can also do some basic information, some basic analysis without, but with the database file is much better. And as you can see, you can also load the SNMP data, the topology. One thing I want to clarify. All this information are all the SNMP data are related to the device. So the device must support SNMP accordingly to Profinet specification. Profinet specification says that well, the latest Profinet specification say that it's mandatory to have SNMP data in the device, not the old devices. It was not in the old specification. So like we have some Siemens device here, they support perfectly the SNMP data, but some devices can be that they do not support it correctly. This is because or they are old or they are not Profinet certified devices. Be careful, because usually it should be mandatory to certify a device. So if you use a device, please be careful that it's a certified device. SNMP is not a Profinet protocol, but is used and is mandatory on the latest protocol and the latest protocol specification. So up to you, Joost.
Yeah, thanks. So you can use loading of Netilities files in combination with Wireshark files to do offsite or remote logging and assisting people on site. We also sometimes do this, although it might be a bit difficult to send large Wireshark files over the internet, but it is possible. Another feature I haven't explained yet is the GSD catalog. Let's go back to an online situation. I will clear this. And well, I've sort of showed you already. In the module configuration, you can see that these modules are currently in this device. But this information comes from the GSD file that I have loaded into Netilities. If you do not load the GSD file, let's see, maybe this one is not loaded. Yeah, then you only see a module identifier. So I don't know exactly what type of module this is or what the name of the module is. So if you load the GSD file of this device into the catalog, then you also get the information from the modules. You get some alarm information. So it explains you more in words what the items are.
So we have another question from Corey, and is how to explain the connection for the setup. In this configuration, well, we can show you live, but I will try to explain you here with the live list and maybe with the topology. We have a Siemens 1200 PLC connected to a Siemens X208 switch that is a full managed switch certified for Profinet. And then we have two Combrix modules for Profinet, one Profinet to Modbus and serial gateway, and one 8200 from Siemens. This is our standard training kit that we use for trainings, for certified trainings, and is compiled to the PI certification guidelines. We are now gathering the topology. That's why the topology and SNMP data are quite important, because you can understand how they are connected. So in this way, in this configuration, they are all connected to the switch, except of the Combrix that is connected to the two modules of the Combrix are in chain, one after the other, and you can see that here. So the main switch is doing your let's say all your switching, and in every port you have one devices. I hope this is clear enough to understand the situation. It's a small network, of course, is what we use for our trainings. But in bigger networks, the topology is really helpful for understanding how your network is connected. If you are the guy who is working on the network and who design a network, it's pretty easy to know how it's designed, also if you have schematics. But sometimes, like us, if you are a troubleshooter, sometimes you don't have even the schematics. You just have a PLC configuration from Siemens, so it's really difficult to find out where is what is devices and where is connected. The flashing information, the topology are really helpful on site to find the device and well, to find the problem. About the other two methods of monitoring, well, they are pretty similar. So the mirror port and the Profinet plus Ethernet port are more or less the same. The main difference is about your switch, because if your switch is not supporting mirror port, like you use an unmanaged switch, you can set up a mirror port. So you need to use the Profinet to analyze the communication. Why you need to have two Ethernet ports? Well, the Profinet is analyzing the Profinet data, so it's sending messages, well, is reading the messages that are sent from the controller to the switch, but is not capable to send any data over the network. This is because it's a protection, it's a barrier if you don't want to interfere in your network. So the second Ethernet port is used for Netilities because it's a I/O supervisor to send data like DCP request to check which device are over the network, ARP messages to see who is on the network that is not a Profinet device, because DCP is a special Profinet protocol, and other switches like other products like not Profinet switches or other kind of devices, laptops, etc., they do not support it. So you need to have another way to ask who is connected, and this is the ARP message. And yeah, in mirror port, some switches like the Siemens here, they support sending and receiving data over the same port. So with only one Ethernet card, you can do that. You can analyze both the data exchange, and you can also analyze the you can also send information, SNMP, DCP, etc. But if you don't have a mirror port, or you can set it because you don't have a managed switch, you have a norm switch, so it's the standard, well, it's the first configuration on the right. In that way, you can't see the data exchange. You can only see, you can only send messages and retrieve response from the device. That's the main limitation of the managed switches. You can't have this. You can have this information. The only way to do that is to connect in the middle with the Profit Hub. The Profit Hub is completely transparent over the network, so it's not giving you any delay or any problem over the network. The only thing is, when you connect it, you need to disconnect the link between the PLC and the switch. So of course, if your plant is running, like most of the time when you are in a troubleshooting situation, you can't disconnect, then you need to set a mirror port. Be careful to set a mirror port on a live situation. Some switches, they stop sending messages when you set a mirror port. Depends of the kind of switch that you use. Not all the switches are the same, and not all the switches behave on the same. I hope this video is clear. We have other few questions, so I will try to answer to everybody. Yeah, Jesper is asking for going through the options on the settings.
Okay. Yeah, okay, we can do that. The options, there are several options that you can use or that you can change to change the behavior of the windows, or of the dialogues and of the colors, things like that. Global settings. The first one is for the Ethernet ports. First one is promiscuous mode, which should always be enabled unless you are using wireless networks. So if you disable this and you want to check a copper segment, then you will probably not see anything, or maybe only broadcasts. So if you are not seeing anything, make sure that this is enabled. Second one is a warning that you can disable. The warning can be displayed when you are not connected to a monitor port or a switch. So it will tell you whenever you only see broadcasts, for example. And you can enable or disable the monitor modes pop-up when you start. When you start Netilities, you can disable this. Let me show you this view. You can if you know about it, then you don't want to see it every time, then you can disable it. You can also disable it here. Show this window at startup. There's an internal buffer size. You might want to increase that if you have slower machines. Then the buffer gets increased, because if you get a lot of packets, then maybe your laptop buffer, memory buffer will get overloaded, and then the data that Netilities must process is not reliable anymore. So in that case, you can increase the packet count. Language, well, that is pretty self-explanatory. You can change it from English to German. If you are interested in a different version or a different language, then we can ask your distributor, or maybe you are the distributor, then you can also translate it, and then we have a new language that we can use included in this software package. The GSD files, you can change the module representation identification. So you maybe want to see an ident number or a name or the code or a description. So you can change that to whatever you want. Then the live list. You can change the colors for devices in data exchange, or active devices or inactive devices. You can change the colors. You can change the size of the rows. So if your screen resolution is not very convenient, then you can change some settings here. The text size can be changed, and also the timing change can be changed. So data exchange activity timeout or general activity timeout, that means that if there's no packet received within 1.5 seconds, then the live list bar goes yellow. And 5 seconds for a DCP warning timeout. So you can change some timing behaviors here of the live list. Also for the statistics, you can change colors, and you can also change the activity timeout for statistics. It's all set to 1.5 seconds. The colors for the bar graph you can change if you like to. And then SNMP scanning timeout. If you are doing an SNMP scan, some devices are relatively slow to respond on a SNMP request. So you set the DCP, or sorry, the SNMP delay to about 3 seconds, maybe 4 or 5 seconds, so that the device has more time to respond with its SNMP data. You can disable a warning about your firewall because maybe that's annoying. And you can set up certain scan ranges. So if I want to make a certain scan range, I add a preset. For example, only machine 2. And machine 2 has an IP address with 192.168.0. It starts at, for example, 40, and it ends at 50, for example. So it will only scan these addresses, these 11 addresses. Now I have made a preset that I can use for the SNMP scanning. If I click scan, then I can say I only want to use these 11 addresses. So it will scan that range only. What else was there? Yeah, you can also change some details about the cable itself. Right now it's set to 190,000 kilometers per second. That's the signal speed of a Profinet cable.
And this is used for analyzing the cable length. There is a little possibility. The device, they tell you how many nanoseconds they are away from each other. So if they are connected in chain, or if, from your switch to your devices, you can see how far they are. It's not exactly precise measurement, because of course we don't have any electrical measurement in Netilities, but it's given to you from the device, so you can see more or less how long is the cable between this device and the other one. Well, the settings are pretty easy actually, and to understand, nothing really really important to check. We have few questions really interesting. I want to do the one from Nikolaus, and yeah, one after the other. The content, yeah, can we monitor the content of the I/O? Yes, it's possible. We saw that when we check for the alarms. So if you go to the live list and you double click on a device like the T200, for example, you go to the module configuration. You see here you have the modules, but you also have the input and output data. And you see they are changing. Right now we are updating the outputs. You put them in auto update and you see the data that is changing. So you can see the inputs and the outputs updated in live on your devices. So if you want to check if it's really sending a message with this output or with this input, you can directly see that in Netilities. Of course, this information is also available on Wireshark, but in Wireshark you need to go deep in the message. You need to know how to analyze the message. Netilities is giving that for you. Already decoded. And there is also another interesting question is about iDevices. Yes, it's possible to use Netilities with iDevices. What is an iDevice? There is a new technology from, let's say, actually right now is only from Siemens. It's still not specified in Profinet, where the two I/O controllers can be can share Profinet message together. So actually, one device is one controller is acting as a device, and the other controller is acting as a controller, and then they share data each other. We don't have a multi-controller situation here, but we can. It's possible to do that. The only thing is the Siemens controllers, they do not reply with a device role when they are in a iDevice situation. So what you need to do is to select manually what side of the data you want to analyze, from which controller you want to see the data. So if you go to the controller and you right click on device role, you can set it, assign as controller or device. So you can say which one of your two controllers is the one who is sending the data and the other one who is receiving the data. Of course, the data exchange is in two sides, but one must be the controller and the other one must be the device. So yes, you can use it also for iDevices. You just need to specify manually which side of the communication you want to analyze, because you are connected on one of the two mirror ports. So you are connected on one of the two PLC usually, and you specify that over there. And also the other question from you, Nicholas, is about the S7 communication. No, it's not possible to use Profinet to analyze the S7 communication deeply. Like you can't see that the data exchange, you can't see the alarms because there is no real data exchange and there is no alarm. The S7 communication is a UDP protocol, a TCP protocol that is sent from two controllers or from the controller outside, like also for safety stuff. I think I'm not a super Siemens expert, but I saw that sometimes. And you can use Netilities for every kind of Ethernet device when we speak about live list and when we speak about SNMP. If the device supports SNMP, even if it's not a Profinet device, you can get the diagnosis, you can get the SNMP information, and you can get the live list. But you can't get the data exchange. So there is no bar graph because there is actually not cycle counter in the message. So there is no way to display the cycle time in a S7 communication. At the end, S7 communication is a really limited way to get. Well, there is no real diagnostics side. So yeah, you can use it. We went on site for a couple of times when they had problem on S7 communication. But all the capabilities of Netilities are actually cut in half. You can only use the Ethernet capabilities, not the Profinet, because S7 communication is not Profinet at all. It's completely different type of communication. And the other question about Corey is, yeah, we don't have the Profit app. How can we establish the connection? Well, as we displayed before, you can use a mirror port we can have a look on that. If maybe we can do that. If you disable, if now we disable the Profit Up in the interfaces, we only keep the Ethernet interface. We are connected. You can clear the data, so we see the difference. We are now connected on a standard port, okay, not on the mirror port, right? So if we start a search of the devices, you see they are all yellow. So they reply to your message because, of course, I can send the data, but I don't see the data exchange. If I now connect on the mirror port, I also see the data exchange. You see, they become green because my Netilities is capable to analyze the messages. And if I go to the bar graph now, I can see the bar graph. Well, it will take about 10 seconds because of the cycle time, but we can display all the Profinet information, because what Netilities is doing is, in the background, is analyzing all the messages. Every single Profinet message is taken from actually WinPickup, the same Profinet, Ethernet analyzer of Wireshark, and is actually analyzed on the background. Be careful. I want to include one thing is this takes a lot of processing power. So if you use old computer, can be that the bar graph is not displayed correctly, or you have some information that is wrong because your computer is not capable to handle all these messages. In a big network, sometimes if you don't configure your network correctly and you keep it like all the devices at 2 milliseconds, you have a huge amount of messages running around on your network, and your computer needs to be able to analyze it. So we recommend to use, in this situation with big networks, to use a powerful laptop. We usually use i5, i7, and with the Ethernet card that you can rely on it, because, well, the Ethernet card is the most important part of your computer for analyzing this information. We usually use Intel Ethernet cards. We recommend to use a powerful computer if you want to do this deep analysis on a big network. When I speak about big, I speak about tens or thousands or hundreds of devices over your network. Every device is set like at 2 milliseconds is sending one message in one direction and one message to the other direction every 2 milliseconds. So your mirror port needs to handle it. And also be careful of the mirror port. Sometimes with big networks, they are not capable to handle all these messages. We saw that with few switches around in the Profinet networks, you can't rely really on the mirror port. That's why we use the Profit Up. Profit Up is only doing the tap configuration, is not also doing the switching. The mirror port is in the switch, so the switch needs to do all the switching first and then the mirror port. So sometimes it's not reliable 100%. I hope this is clear enough. If you have any questions, write it down. You're welcome, Nicholas, for the thank you. Do you have to assign address of the Profit Up? Yes and no. No, because it's just sending the data that is receiving. So you see here is set as 0000, and we get the data anyway. Yes, if you don't want to have your Windows computer try to send data over this network. So let's say you have two network cards connected, one with 192.168.0 something, and the other one 192.168.5. If you're browsing on the 5, of course, you need to give the IP address. So in that way, Windows is not trying to reach the 5 network on the other side, and is also not sending continuously messages to your top devices, like broadcast, trying to connect over the network, try to set up connection, try DHCP, request, etc. So it's not mandatory. We usually don't do that all the time. But if you see a Wireshark trace with a Profit Up with a set IP address and without a set IP address, there is a difference. There are a lot of less Windows messages when you set the IP address. I think we answered to all the questions we have. Do you have any further questions about Netilities, about your Profinet configuration? We are here for you. We still have more or less half an hour. Is everything clear? Can we clear something more for you? Any question? Please write it down. We are here for you.
In the meantime, I would also like to point out that we have trainings that cover Netilities and that also cover Wireshark. And these trainings help you to troubleshoot your Profinet network. It's Profinet Troubleshooting and Maintenance. Next dates are June 27, June 28, here in our office, I believe. We also have the certified Profinet engineer training, which is concluded with an exam. And if you pass the exam, then you are a registered certified Profinet engineer. And your name will also be on the Profinet International website and also on our website. So customers can find you and see that you are a certified engineer.
And just want to add that we can also do these trainings on site for you, for your company, for you as a distributor. And we also, it's still not on the website, but we are also planning in June one date for Italian training, TNM Profinet in our office in Brescia. I saw there are a couple of Italian guys in the webinar, so I want to add it, this information. We do certified trainings with our training kits all around the world, and also TNMs. They are really, really important in my opinion. It's not only because I'm one of the trainers, but because they are really, really helpful. I started doing troubleshooting on Profinet without having this certification, and after the certification, it's much more easier to work on Profinet. It's quite interesting. Another couple of questions from Jesper. We have to show again how to import the GSD file. Yes, so of course we can do that, no problem. It's pretty easy.
Yeah, go to options, then GSD catalog, and here we see all the imported GSDs already. But if I want to add files, then I click add, and I go to my GSD catalog on my computer, and then I say I want to add maybe this Beckhoff GSDML. I open it, and then here it is. And then I recreate the GSD library. And then it should be here somewhere. Let me try to find it. I think it's this one. This I just added to the system. So now my Netilities also knows this Beckhoff device.
Another question is about ProfitUp and ProfiSafe. Yes, Netilities and ProfiSafe. Yes, it's possible to use Netilities with ProfiSafe. For ProfiSafe, actually, what is ProfiSafe is actually encapsulated inside a Profinet message. We don't look inside the message, but it's possible to do all the bar graph analysis, all the SNMP information, etc., on a ProfiSafe network all the time without any problem. ProfiSafe is actually inside the Profinet message. It's not really it's not a separate protocol. It's exactly the same protocol on the cable, let's say. And the other thing is okay to use Netilities inside a virtual machine? Yes, is okay. You can do that. You need to connect correctly the Ethernet card, of course. We do that. We use it sometimes, but be careful because the processing power of the virtual machine is cutting out your processing power for your real device.
Actually, I have some trouble using it in my virtual box or virtual machine because the app dongle, what it does, it creates a hidden partition on the drive, which contains parts of the program. So I don't think that is possible to use in a virtual.
You need to enable the two drives. So in the settings, you will see two different drives, and you need to enable both of them. With VirtualBox, I already tried, it's working. I don't know if VMware you usually use it, but yeah, it should be more or less the same configuration. Yeah, you need to enable the drive and the Ethernet cards correctly, and then it's working. Be careful only on the processing power, because if you have a huge network, you need a lot of horses around to handle all this information. Does exactly work the same with VIPA system? If VIPA is using Profinet, yes. The only thing, be careful that the devices support SNMP correctly, and be careful that is a real Profinet communication. I think, yes, VIPA systems are quite good in that, so it should be working fine. We don't have any VIPA devices in our training kits right now, but yeah, maybe we can give it a try. It should work fine. It's Profinet and is an open standard for every company. What we saw around the main issues is some devices, mostly cheap companies or rebrands or stuff, they do not support all the features that Profinet is capable. Like SNMP is mandatory only in the latest Profinet version, and the latest Profinet version is it was released 2 years ago, something like that. So a lot of devices around are still in Profinet version, what is 2.2, I think, yeah, 2.2, which says it's better to use SNMP, but it's not mandatory. So when you see that a device is not sending you SNMP data, is because it's not supporting it. And this is really pain when you troubleshoot a network, because without a managed switch, without SNMP information, you don't have the errors, and you don't have topology, you don't have everything that is helping you to fix the problems over the network. So yeah, should be working fine. Be careful. We saw that some switches that do not support SNMP around, even if they are managed. So when you pick a switch for your network, be careful. This is more a designing thing, but the switch is the most important part of your network after the PLC. So you need to be really careful that it's capable to handle all the communication fine. In the live list, will it show device info only during errors like on Profibus? In the live list is showing you, yeah, if you double click, you have the information from the device, and this information are retrieved from the INM information that your device is sending. So there is a cyclical communication in Profinet. It's called INM, and INM 0 is mandatory for Profinet devices. So this information is retrieved like this, and also like with the DCP request message. When you click on the little binoculars, the green binoculars, your Netilities is actually sending a DCP to all the devices over your network. And the Profinet device, they answer with a reply telling the MAC address and all this information. You see when we click it, we retrieve this information. Thank you. You're welcome. I think we answered all of them. If we have something more, we're here. Only one thing we want to let you know is, well, if you are interested in Netilities, if you still don't have it, feel free to contact us. Well, not us directly, our sales department or your local distributor. We just announced a new tool for Ethernet. Maybe it's nice to have a little show around. It's Atlas. We just released and announced it during the Hannover Messe fair in Germany. I would suggest to have a look on our website. Is actually what Netilities is doing that on your computer. There is no real permanent solution for monitoring over Ethernet right now, and Atlas is the idea. Is the idea for our future. Have a look on what is Ethernet actually and how is going to go over your and our networks. Atlas is going to be an open device who is capable to analyze not only Profinet but all the Ethernet protocols, and it wants to do that in the easiest way as possible for people over the plan to analyze it and troubleshoot your network. Just have a look on Procentec website. It's just released. It is quite interesting to look. Okay, so are there any other questions? If we don't have any further question, I would say we can say hello to everybody. Thank you for your attention, and we will see each other next time. There is going to be a profit race webinar, a convex webinar. I think is the 16th of May. If you have any question, feel free to send us an email for any sales information, info@procentec.com. For any technical question, support@procentec.com. We do on-site troubleshooting, we do on-site analysis of your network, and we also do trainings all around the world. So feel free to contact us if you have any problem, any question. We are here for helping you. Don't worry. Thank you very much. Thank you, Joost. See you next time. Have a nice day.